Hi everybody, welcome back. Okay, so last we were talking about how these methods were not actually as simple as we thought, because the data we're taking when calculating du dx or dv dy is no longer overlapped. So it means my continuity equations really don't work because this is an average between one point in x and y and a second point in x and y, and those points were not the same points. I tried to order it here so you could see that, and this is roughly how it would work. So even if I had a matrix that was the same size, it still wouldn't have worked nicely. So averages. If only I had a way of being able to take exactly what u, v, x, and y are at any particular point I want. Like x and y is continuous, y is in my velocity field continuous. Well, I can't just magically create data. However, MATLAB has built into it some wonderful functions. Now, one of those ones I'm going to try to show you right here. So this, if you look at it, it suddenly gets very, very dark only because this one has a lot more data points. These are actually the same data set. However, what I did was I used a built-in function that's in MATLAB. It's called griddedInterpolant. Now, what does it do? Well, it simply says if I have an x and y grid, and I have a grid of z data, some other data, that goes along with that x and y, I can create a new tool which is interpolated such that I can pick anything I want, any data point I want, from inside of my data set, and it will interpolate using the values it knew to find a new value in between. Is it exactly correct? No, it's interpolation, but it's still better than what we had before. And as a note, if I pick a point that I already had, it will give me the exact value. So long as I'm choosing data points that I already knew, it will give me that data back. So what I did right here is I did that, and I used my griddedInterpolant to calculate all the values in between what I had before. And it matches the real function very, very well. Okay, some other things to know about here. You can't use mesh grid, you have to use an ND grid, which is a different type of grid. I'm not going to make you really think about that too much. If you're used to mesh grid, it's very, very easy to change. Like all of our grids that we got earlier were mesh grids. And so what you would have to do in that case is you just simply add a prime here. So that takes a mesh grid and turns it into an ND grid. You can use it automatically. So that's what I'm doing right here. I want to have all my u values and all of my v values just everywhere. And so I'm creating this tool, a griddedInterpolant, that takes the values I know and then allows me to choose any point in between and get values I don't know. The nice thing about that is I can then, if I want to, choose any particular point. So this one right here is if I was trying to calculate the change of the u component, sorry, the x component of the velocity in the x direction. What I can do is I can simply take a very, very small step in the x direction at that point. So I did 0.001. I could have very well done 0.0001. And I can get du from that. Now these values are taken from my griddedInterpolant. That means it's interpolated values. They're not the actual values. So I am adding error as I do that. But hopefully those errors are small compared to what I'm doing. And so if I calculate that, I get a derivative of negative 37.5143. And the smaller my step size, likely the closer I would get to being exact. So I'm going to try this again, run section, and I got the exact same value. So I'm already at exact. Now, the larger my step size, the more error I'm going to have when calculating a derivative. Dang, okay, this one's actually doing pretty good. Let's try, okay, let's be really big and obnoxious here. And if it doesn't change this time, well, I'm just being crazy. Okay, there we go, run section. And it still worked out just fine. I'm guessing I just supposed to have a really good interpolant, or it's changing linearly in that direction, so it doesn't matter too much. This is also a pretty small step size still. I mean, at least for my data, but the data was set based before by 1. Okay, but that is it. That is the tool I wanted to give you, which is this griddedInterpolant. It's a way of getting values that you don't have through interpolation. You could write your own code to do that, but why write your own code when they'll do it for you? And using this, you can do some fun things. Like, for example, if I can calculate du dx and dv dy at any point I need in space, I can figure out what direction I need to go such that adding those two would be 0. Because du dx and dv dy, if I take the dot of that with a particular direction, I can find a direction that would be equal to 0. And if I find that direction, that's the direction that the particle would follow, because that would match a streamline. So, a little hint there for something later, but hopefully you're paying attention. Either way, if you got questions, you can always ask me. So, that's it for this time. Thank you all for listening. I hope this helps you. I'll see you all later. Have a great day.